Okay, let's get started. Welcome to this session about developing microservices with Dapr. It's great to be here. My name is Jakob Ehn. I work at a company called Active Solution back in Stockholm, Sweden. I'm an Azure MVP. I have a lot of interest in not just cloud architecture, also DevOps. I've written a few books on the topic, which is nothing that I really recommend unless you're interested in wasting a lot of time without making any real money. But it was a good experience anyway, and it's great to be back here in Oslo, actually. I used to work for a Norwegian company for many years, so I have run into a few old colleagues and friends here. So really nice to be here. And so this talk is about Dapr, which is a framework for kind of developing microservices. So just to set the context here, what is hard about microservices, and actually there's a lot of things that is hard with working or developing with microservices. But if you think about the core idea behind microservices, where you take your system and you break them down into smaller pieces, where each service could be potentially developed by their own team. And ideally, each team should be able to select their own technology stack, their own type of storage, the technology that really fits that service. And if you do this right, that could really give you a lot of benefits. And really create agile teams which can work at speed and develop and deploying their service without worrying about the rest of the system. But the flip side of that is that now you have, instead of like this big homogeneous system, you have a lot of smaller services where each service have like a different technology stack, different platform, different way of building, packaging, deploying that service. So it's a lot of things that you need to build. And since this is now a distributed system, you need to think about things like how do you do tracing, like distributed tracing? How do you do things like service discovery, resilience? What do you do when your service call fails and so on? And these are things that is like cross-cutting concerns. It's not really tied to your business domain, right? This is technical things that you just need to solve. And it's not that this is super hard or super complicated. But you need to do it, and you need to do it in all these services. And again, this could be now, one service could be developed in .NET Core, another one could be Java, the third could be Python, right? Different type of storage. So a lot of things to worry about. And this is really the core idea behind Dapr, to try to make this easier for you, try to codify best practices within this area. So Dapr stands for Distributed Application Runtime. So this is an open source project. You can read all about it at the Dapr.io. And they went like generally available for 3 or 4 months ago. So it's production support for this runtime. And the core goals behind Dapr is to kind of build these best practices building blocks that you can use. So you don't have to write this code to kind of implement all these things that you need to implement. And it's not tied to any particular language or framework. Today I will show you a demo with .NET Core, but supports really any kind of language that you want to use, which is, again, really a core idea with microservices. You shouldn't be tied into a specific technology stack. And it's community-driven, so it's a completely open source. You can join their weekly stand-ups if you want to, and kind of affect the future of this project. And it's also agnostic in terms of where do you want to run this. So you can run this on-premise, on your local machine, on your servers, on any cloud. So Kubernetes is one of the kind of fitting platforms, but there are other options as well. And also importantly, it's extensible and pluggable. So these components that implement these building blocks, you can build new ones, and new ones are being developed as we speak. So here are the list of the current building blocks. So just to mention a few of them now is the first one, which is really obvious one, is the service-to-service invocation. So of course you need a way to call, make a call between your services. And when you're building distributed systems that consist of multiple services, and these services could be running on multiple machines, you need a way to find where is my service actually located right now. And I shouldn't have to worry about that. I should just be able to make a call to a service, and then something should do the service discovery for me. We have state management. So this is basically a kind of a key value, an abstraction of a key value store. So you can store things in like a Redis cache, Cosmos DB, and so on. And it's not just for storing and retrieving value. It also solves like these problems of, for example, handling transient failures, doing transactions across multiple writes, these kind of things that you shouldn't have to write yourself. This is things that the people can implement for you, test it, and then you should just be able to use it. Publish, subscribe, very common pattern for doing event-driven distributed systems. Resource binding and triggers. This is a way for letting your applications communicate with other systems. For example, being triggered by an event outside of your system, or making a call to some external API, for example. So again, there are now a lot of already implemented components that just make this a lot easier for you. And a few more blocks. There is actually an actor building block, which is an implementation of the virtual actor pattern, which is a very specific pattern. So if you're interested in that, definitely check it out. I won't mention it in this talk, but it's there. Observability, again, super important. So you get things like metrics, distributed tracings, which will help you to troubleshoot your system, which again is just harder when you have now a distributed system with many running things at the same time. How do you actually know, when you get a bug in one service, how do you know which service called that service? You want to be able to trace it all the way back, just to make it easier for you to find the errors. So, but what's common about all these building blocks now is that these are now, you communicate or you use them through standard protocols like HTTP or gRPC. And this is an important point now, because it means that's the reason why it's not tied to any specific language or runtime. Anything that can speak HTTP or gRPC will be able to use Dapper, because that's how you communicate with it. So that's a very that's a choice they made. And what they're using to implement this is something called the sidecar. So sidecar is really a distributed system pattern. It's a design pattern that's very, very common. So if you take a look at an application that consists of two services, and these two services wants to talk to each other, so we want to do service invocation, right? So instead of just finding out where is service B running right now and make a call to it, instead of that, we're going to communicate with our sidecar. So when you're using Dapper, every time you launch your service, it will have a sidecar, so a separate process running next to it. And that's what you communicate with. And you do that using, again, HTTP or gRPC. You can select that yourself. So when I want to communicate with service B here, I will actually just make a call to the Dapper sidecar. It will actually make a call to service B's sidecar, and then that sidecar will now call that service. So it's a level of indirection here, which actually, this is where all the functionality and kind of the magic about Dapper happens. So it will do the service discovery for me. I just need to know basically the name of the service and the method I want to call. And the Dapper sidecar will now find it for me. In addition to that, it will add things like the observability, for example. So the tracing and log and metrics and so on. It's just, I get that for free. I don't need to do anything to get that. It also secures the communication between the sidecars. So you get the TLS for free as well, which is very nice. So for the rest of the building blocks that you want to use, you need to specify, okay, which of these building blocks do I want to use, and which implementations of it. And this is done using component YAML files. So you specify a component file that says which, for example, which do I want to use a state store or not. And if I want to use a state store, which type of state store? Do I want to use Redis or Cosmos DB or something like that? So I specify this in a YAML file, which I'll use then when I run my system. So, and the YAML files, again, this is now allows you to use things like the state stores. You can use the publish subscribes, building blocks, the resource bindings. And again, there are now many, many implementations of these building blocks. So you have a lot of different options here. So again, for example, if you're using state store, you can select to store your state in Redis, in Cosmos DB, in AWS DynamoDB, and so on. This is a long list, and it keeps growing because this is community driven. So the number of options here will just rise along the way here. So again, sidecar model. You have your application. It speaks to the Dapper sidecar, and this is how the URL actually looks beneath the surface. And so the default port here will be 3500. And this will be running next to your service. That's really all you need to know. And again, if, for example, if you want to do service invocation, you can see that that's the first example there. So /invoke, that's how you actually call, for example, the method call new order on the cart service. The next one is the state. So the URL format is /state, and then the name of your state store. And for example, give me the item with the ID, item 67, for example. So this is really all you need to do to use these building blocks. Just codify these HTTP URLs. You can also use gRPC, as I mentioned. Now, there are many SDKs available, which makes it even more easier. You don't actually have to write this HTTP code. And I will show you an example of that in the demo later. So it makes it even easier. But it's important to realize it's just HTTP, which allows you to use anything you want that can speak HTTP. You just need to make sure that your Dapper sidecar is running next to your application. The component files can look like this. This is a YAML file. Of course, everything is YAML nowadays because we all love it. And kind of the key thing here is the type of the components. In this case, this is the Azure Service Bus. And depending on the type here, it will have a set of metadata that is specific to that service, of course. So in the case of a service bus, you need to define a connection string and so on. And then you can see that the component also has a name. In this case, the name is message bus. And that's really all I need to know later on in my program. If I want to kind of talk to this service, the Azure Service Bus service, I just need to refer to the name message bus, and then Dapper will handle that for me. So it's really a nice abstraction that keeps all of these implementation details away from your application and just makes it really pluggable, which is really nice. So again, I'm just going to walk through a few of these just to kind of explain how it actually works, and then I will dive into a demo. So again, service invocation, like this is really basic. This is something basically all systems will use. Again, if you want to call to, for example, this case we have the front end, it makes a call to the cart service. It actually calls the Dapper. So you'll make a post to your Dapper sidecar. In this case, I'm calling the API/checkout method on my cart service, and I post some data to it. The Dapper sidecar will then speak to the other sidecar, and this communication is always done using gRPC because it just is much faster than HTTP. So you can select HTTP or gRPC when you speak to the sidecar, but between the sidecars, it's always gRPC. And then that sidecar will then actually make the post to the cart service and then return the answer back to the front end. And you don't really notice this. It's just done behind the scene. But again, in addition to do this service discovery, you get things like automatic retries, for example. If you get transient failures, it will actually retry it for you. You get secure communication, and also you get the observability kind of for free. So really helps you with debugging your systems when or if they will fail. Also to understand things like performance and so on. State management, again, this is a key value implementation, but again, a value could, of course, is a document. You can store any complex object in here. So again, if you want to store something, you'll make a post to the state URL, specifying the name of the state store, and then you pass in a key and a value, basically. So again, this could be a simple integer or string, or it could be a complex document. And again, Dapper will then store that data for me, and depending on my component YAML file, it will be stored now in the state store that I chose, be it Redis or Cosmos and so on. And of course, you can be able to retrieve this information later on after you saved it. So you can do a get. There's also a query API that you can use. And again, these are abstractions now because they need to work with all of these underlying implementations. And of course, there will be cases when this is not enough. If you have like a heavy investment in Cosmos DB and you do a lot of weird things, this building block might not be enough, and then you can just select to go directly to Cosmos DB. But in many cases, these building blocks will be enough for your services. And if you have many services, you could have like 20, 50, 100 services. It just makes a lot of sense to keep this simple, in my opinion. So you don't need to complicate things by writing this stuff yourself. But if you need to, you can, of course, do that. You don't have to use Dapper for everything, right? Again, you have things like optimistic concurrency. You get that for free. Automatic retries again. You can also do transactions if you do multiple writes. So these are things that you typically might miss to do. Maybe you don't think about it until you're actually in production. Here, you kind of get that for free. Pub/sub, again, you're starting to see the pattern here. When you want to publish an event, you do that through your sidecar. You can select the type of message bus that you want to use. So Redis or RabbitMQ and Service Bus, Azure Service Bus. So you publish an event, and you can specify any number of subscribers to that to the topic of your service bus. So of course, very, very common pattern in distributed systems, event-driven systems, to do the pub/sub communication form. Again, it has things like at least once guarantee. You can specify message time to live and so on. And these are also things that are being developed. It's being improved along the way, of course. So if you are starting to use Dapr, you will actually, you will get more functionality along the way, because this is a thing that people are working on. And it's open source, so you can contribute yourself. Okay, so let's dive into a demo here. So how you actually get started with Dapr and how it actually works. So I'm having a super simple sample application here with 3 components. So we have like a web application, we have an API that will actually store an order for me, and then I have a kind of a background thing called a warehouse API that will eventually listen to an event when an order is created and then do something. So I'm going to try to show some of these building blocks, how it actually works. So of course we'll do service invocation between the web and the API. We'll do pub/sub. So when we get an order in the API, we'll also raise or publish an event that the API will listen to. So we'll store the state in either Redis or Cosmos DB. I think we'll do both. If we have time, we'll also see how we can trigger this from the outside world. So for example, if we get an event on a service bus, how can we trigger our application from that? And also an example of the output bindings, as they're called, or the triggers. So in this case, I'll send a message through Twilio every time I receive this order publish event. So that's kind of the scope of this demo. So let's jump straight into VS Code. And so these are the 3 applications that I talked about, the API and the web and the warehouse API. And this is the standard .NET Core, ASP.NET Core applications. And just to show you, how do you run Dapr with your applications? Because the thing is, you need to have this the sidecar running next to your application. So one way of doing that, if I would run this application in the normal way, I would do a .NET run, and it will run my .NET Core application. So you know that, of course. But in this case, I need to run my application and the Dapr sidecar. So actually, what I could do is to use the Dapper CLI. So I'm going to zoom in a little bit here. So I have the Dapper CLI. That's a CLI you can use, for example, to run the sidecar and also do a few other things. And so what I do now, I'll do a Dapper run. And first up, I need to specify the app ID. So that's the identification of my application. That's how other applications or services will know how to communicate with my service. So when I run the order API service, I will give it the app ID order API. And again, that's all the other services need to know. I also need to specify the port that my application listens to, so the sidecar can actually communicate with my service. That's the app port. I can specify the Dapper HTTP port. So by default, this is 3500. So I didn't have to specify that here. But if you want to run multiple services on one machine, like I will do now, you actually have to make sure that you can't listen to the same port. So if I would run another one, I would have to specify a different port here. And then at the end there, I have the .NET run. So again, I want to start my application as well. So the Dapper CLI actually lets me start the sidecar and my application in one simple command. So to show you this, I will run. And it actually now shows me, when I run it like this, it will show me the output from the sidecar. So everything in white here, that's coming from the sidecar. So there's a lot of details here. It initializes, it reads component files, and yada, 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 a lot of stuff. I can also see the output here in blue, which comes from my application. That's the standard ASP.NET Core output. So it's just mixed into one log output here, which is quite nice. So again, now I have my order API running. And so if I would just go to the normal endpoint here, for example, /order, I will just hit my API endpoint. So now I'm not really using Dapr now. I'm just hitting my API. But what I could do now is I could actually access the same endpoint through Dapr. So that's the URL that I just hit. But I can also use this URL. So let's just hit it first. And of course, I get back the same result. So if you remember from the slide that I showed you, that's the URL format for service invocation. So now I actually communicate to my API endpoint through the Dapr sidecar. So I do /invoke, I do the name of the service, order API, and then you have the method, which is called the order in this case. So that's all you need to know to actually speak to the service. And what's important to realize here is that now I don't have to know where that service is running. I just speak to my sidecar. In the first example, I needed to know that it's actually listening to port 5109. And of course, now this is just one machine. This could be running on a distributed system with multiple machines. So service discovery like this just makes a lot of things a lot simpler. Okay, so that is that's how you can use the CLI. Now, typically, you don't want to run this CLI for every service that you're running. You could have 10 or 15 services in your solution. So you typically don't want to hit Dapr run for each of your services when you're trying to run them and debug them and so on. So if you're using VS Code, there is a nice extension for Dapr. And what this does, it has a few different functionalities, but one of them is to make it easier for you to work with Dapr in VS Code. So it will actually help you to create this launch and task configuration. So if you're working with VS Code, you know that you can create launch configurations to specify how do you start and debug your applications. And it will actually help you to scaffold these things automatically. And so for example, if we're going to run the order API, I have a launch configuration here called order API Dapr. So it's actually a standard ASP.NET Core launch configuration with two differences. It has this pre-launch task here, and then they have the post-debug task here. So again, the pre-launch task, if you just hit quickly into here, this now comes with the extension, and this is now actually what starts the sidecar. So here again, you can see a little bit of the information that I passed manually to the Dapr CLI. Here I just specify that in this task. So I give it the app ID, I give it the port, the HTTP port, and a few other things. And this is nice now, because when I have all this in place, I can just hit F5 like usual, and it will start all my services with the Dapr sidecars. I can debug them, just like any other application, because you want to keep that, that inner flow, and to have that fast. Okay, so let's see how we actually use Dapr now in an application. So if you go to the web application, which is just super simple, I will create an order. When I do that, I want to call the order API here. And so what I do now, I will instantiate the Dapper client. So now I'm using the Sdk now, the NuGet package for Dapr. And let me just show you. I already installed it before. So I have this Dapper client NuGet package installed for me. And this is just makes it easier for me. Now I don't have to create that URL format that I showed you before. I can just I can use this object model instead. So I'll create a client, and if I do see what's in there, you can see that we have now methods for these various building blocks. So for example, we have the invoke method, that's how we do service invocation. I have invoke binding to communicate with external systems. We have publish event and so on. So this will create the correct URL formats for me, so it just makes it a lot simpler. So let's call the API then. So I'll just do an await here. And let's do an invoke method async. So in this case, I'm going to post the order to the API. So I'm going to do pass that as a type argument. And so for the parameters now, the only thing I really need to know now, again, is the name of the service that I want to talk to and the method. So the first one is the app ID, which is now order API, right? That's what we specified. And the method in this case is just called the order. It's the default post method. And the last argument is the actual data that I want to pass. So I'm just going to pass the order here. So that's really all I need to do to actually do service invocation. So the web will now call the API. Let's head over to the API now to see, because I don't want to just pass the order around. I actually want to save it as well. So we will eventually wind up here in the post order method in my API. It will receive the order. So again, I will create this one. And again, you can do. You can actually inject this. I don't have to do it like this way, but just to make it clear what actually happens, I'll create this client kind of manually in each method. So in this case, I want to store this data. So I do a client, and then I could, client.save state. And again, I could pass the type here, because I want to save a type order. And again, now I need to specify the state store, the name of my state store. So I'm just going to pass actually a state store here. I will get back to that. I need to specify the key for my data. So in this case, I would typically use the ID for the order. And finally, I need to pass the value, so the order itself. So that's it. And let's run this. So let's set a breakpoint here. And we'll do an F5. So that's my beautiful web page where I can create an order. And let's just type something here, NDC hoodie. And I want to have 3 of them. So we hit the breakpoint here. And so you can see now that we actually come to the API endpoint. So it was actually properly called from my web. It did the service invocation to the API. And it also stored my order here. So let's just take a look at the order that was passed here. So we can see it has the NDC hoodie, the quantity was 3, and so on. And it was saved. So, okay, but what actually happened? Where is that order saved now? So by default, when you're installing Dapper, it will actually also spin up a Redis instance for you, just to make it really easy to get started and to work locally. So by default, you will get the state store, which is called state store, which is using Redis as its backing service. So to actually show you where it ended up, I have a Redis Explorer here. And so you can see now it actually has this new entry here that was just created. And this is actually where my data wound up. You can see the data coming in here. So this just happened automatically. And the reason why this actually works is, again, when you install Dapper, you will get this, in your user profile, you get this .dapper folder. Inside there, you have some default components and configuration. If you go into this components directory, you can see we have 2 YAML files here, one for pub/sub and one for state store. So just to open this one and zoom in a little bit, this is the default state store you get. So again, uses Redis on your local machine, and that's why that save state just worked without me having to do anything extra. So super simple to get started. And again, the name is the key here, so that's why I specified state store in my code. So the name is really the key here. But let's say I don't want to use Redis for my state store. I want to use Cosmos, for example. Then I need to provide my own component files. So I have a folder now which is empty called components, and we'll copy an existing one here. So let's drag this one here and take a look at it. So this is the same, it's a component file. It has the same name, state store, but in this case I'm using state Azure Cosmos DB. And then I have some information that's specific to this one. And again, you don't have to have secret information like I do now. You can use, for example, a key vault and tie that in automatically. So this is just simpler, maybe for you to understand. So again, the type is the Cosmos DB. The metadata is how can actually Dapr will communicate with the Cosmos. So let's run the same code again. And to do that, I need to stop my sidecars because it needs to reload this file. And I need to do one more thing. I need to specify now the path where my component files are located. So I will add to all of these three. I will add a component path, which is to /components. So that's actually how Dapr will know where my component files are. So to my three different API, warehouse, and the web. So now it knows where to look for it. So let's do an F5 and run the same thing again. So let's do an NDC hoodie 2. And we get a breakpoint. Just run that. And again, now we shouldn't see a new entry here, and we don't. So the reason for that now, of course, is that it actually was stored in my Cosmos DB account. And just to show you that I'm not lying, let's just take a look here. So this is the Cosmos DB account that I'm using, and let's check the order one, and we should see one item here now. Maybe we could zoom in a little bit here. So again, you can see the same information. You have the item and the quantity, and then you have a lot of kind of Cosmos-specific stuff. But that wasn't anything that I needed to actually to worry about. That was just done automatically by Dapr. So you can see how easy it is to just plug a component in, and the communication will just work without me having to write any code for it. I could potentially run Redis locally and then use Cosmos DB for my testing and production environment if I want to. But I think the main thing is that you don't have to do the implementation yourself. The possibility of switching components, different type storage, that's nice, but it's not, that's not so common that you do that. It's more about having the kind of the best practice implementation there. Okay, so let's move on to do some pub sub. So when I save this order, I also want to raise an event to let anyone know that actually I stored a new order. So I use the same client object. In this case, I will do now a publish event. So we have the publish event async. Let's pass the order. And I will give it the name. So this is corresponding to the state store name like we did before. Now I need to specify the name of my pub sub store. So I have a component file that I will use, and the name of that one is order pub sub. And then I specify the topic. So this is what the subscribers actually will listen to. So you can have multiple topics, and the subscribers will listen to that topic. And this one is called order. And again, the last one is the data itself, so I'll just do an order. So that's it. That's everything I need to do. And let's head over to the last one, the last service, the warehouse API, which we should then listen to this order. And what I need to do now is actually we can leave the method like this. And now we just need to add some component files here. So I need to specify what kind of pub sub service or component I want to use. So in this case, let's grab one from here. I'll use this one, the pub sub, which is under the hood just using Redis. So that's the default, but I could, for example, use the Azure Service Bus here if I want to. So that's for publishing events. Then in order to actually subscribe to the events, I can, for example, also use a component file for that. So I have a subscription file here. This could actually also be done in code. But for the subscribers here, I specify the name of the pub sub, the topic I want to listen to, and where those messages should be routed. So it should be routed to the order created endpoint in the services. And here you can also see the scopes at the end here. Oops, sorry. So that's actually how I can filter these events. So because I don't want to have all the services having this event routed to them. I want to specify only for which subscribers are actually interested in this one. So in this case, it's the warehouse API that should actually receive it. So actually, let's do one more thing at the same time before we run that one. Because I also want to show you an example of actually, let's wait with that one. We'll come back to that one. So let's stop the sidecars, because we added some new components. And let's stop here. So let's just build it and run it. And I think I had a breakpoint at the end here. So let's send another order. Test 43. And I guess we get a breakpoint here in actually after the publish event. Let's keep running and see, did I add a breakpoint in that method? I did, so it actually should have been called now. Let's see, did we add the subscription? We did. Let's stop the sidecars. Okay, let's try that one more time. So it should hit my endpoint over here. Let's put a breakpoint there as well. Send this one again. Okay, so for some reason it actually didn't hit my API endpoint here, so it should. I'm not sure why that didn't work. Okay, but anyway, that usually works when I do this demo, but for some reason the pubs didn't work here. But okay, let's continue to kind of the last block that I wanted to show you, which was actually supposed to run here, but instead let's run that from the order API instead. Because I want to show you how you can also trigger or kind of communicate with external systems here, both like input and output. So one way we could do here is to send a message every time we get an order. So I'll do an invoke binding here. I want to send a message through the Twilio service. So I have a Twilio component defined. So if you have, it's a very nice cloud service for sending various types of messages. And let's go to my folder here. Let's copy the Twilio component. So again, information to my account, which will actually now send a text message. And the name of the component is Twilio. So that means when I write this code, I will specify the name here. So I'll do an async. I'll add the name of the component. And the operation in this case will be a create. And then I will also add a text message. So let's type order created and just pass in the order ID, for example. So let's run this one. See if this one makes me a little bit happier. It should work. Some quantity. And we get a breakpoint. The first one, let's run again. It ran through here. And, well, you probably didn't hear, but I actually got a text message here. Very powerful demonstration. You can come up afterwards and actually see I actually got a text message. It says order created, and it's a nice GUID. Okay, but again, one line of code. That's all I needed to actually communicate with, in this case, Twilio. So that's an example of an output binding where I communicate with an external system like outbound. Another way is to trigger the system from the outside world using inbound. So let's say that now, instead of just receiving orders from the web application, I also want to be able to reach it through a service bus coming from an external system. So let's try that. And again, to do that, I need to have a component file to specify, which service bus should I use. So let's stop this one, and let's add the last one here. It's the binding here to the service bus. Let's copy it here. And again, I'm using, in this case, the type is the bindings Azure Service Bus queues, and then connection string and so on to specify how to communicate with that service bus. And since I have that now, I should just be able to run this. And let's head over to my service bus. So it's Dapr demo. Queue. So if you're using Azure Service Bus, you know that you can actually go in here and just send a test message. So I'll use the Service Bus Explorer, and maybe we can zoom in a bit. Okay, never mind. So I'll just send a sample order here. So I'll just select JSON here, and then I'm just going to copy a sample order in JSON format here. So I just need to pass the item and the quantity here, really, like that, and send it. And you can see now that it immediately hits my breakpoint. So let's check the order that come in here. You can see racing car 42. So again, now I actually didn't write any code at all. I just added the component file, and that message is now received automatically from the service bus. And so you see how easy it is now to build connected systems like that, both synchronous and asynchronous, with very, very little code. And it's not just the functionality of actually communicating with that particular service. It's also handling things like retries in case of failures and observability and so on. Okay, let's switch back to the presentation and talk a little bit about hosting these things. So hopefully you got a good sense of how you actually work with these things, how to get started. And so when you're hosting this, you can do this self-hosted. This is really what I did now on my local machine, and you could do the same thing on in a production environment. But typically you would use something like Kubernetes for your platform. Now you can also use Azure Container Apps, which was actually announced in preview at Ignite, which is a new, really kind of a serverless Kubernetes service, which will eventually make it just much more simpler for you to host your microservices without having to know a lot of details about, for example, Kubernetes. So, but in the case of self-hosted, we did this Dapper run, as the slide shows here. So you run your application, you run your sidecar. The other things actually runs like Docker containers on your machine. So the Redis, the Zipkin for the tracing and so on, that will actually run like Docker containers on your machine where you're running these things. But again, I'd say this is mostly for local development, I would say, when you do self-hosted. So if you're on Kubernetes, what you can do through the Dapper CLI, you can do Dapr init-k. It will actually deploy the Dapper components to your cluster. And then you can actually just deploy your application, of course, but also the component files. You can take them just as they are and deploy them into Kubernetes, because Dapper actually creates what's called a custom resource definition. So then it will actually understand the same component files. So it's really, really simple to take this application that I just showed you and just deploy it to Kubernetes. I just deployed the same files that I just showed you. And in your deployment manifests, where I marked the red square there, you add a few annotations to it. And this is the trigger for Dapper to tell you, this is actually a Dapper application. I want you to start a Dapper sidecar. That's the Dapper IO enabled annotation here. So that's kind of the magic. And again, then you have these different things that I showed you before, the app ID, the protocol, and so on. And I will actually show you that in a quick demo afterwards. So again, what actually happens, behind the scene is that when when you spin up a pod in Kubernetes with your container in it, the Dapper operator will also inject the sidecar into that pod, just by magic. You don't have to worry about it. But again, the communication work. And you just need to know the name of the service to talk to. You don't need to change anything. You can run it exactly in the same way as you do locally, but in this time it's in Kubernetes. And I wanted also to show you the possibility of now using Azure Container Apps if you're in Azure. So this is something you should look into if you're doing microservices, but maybe you haven't invested a lot of time and effort to learn Kubernetes. And I think we'll see more of these types of solutions going forward from various cloud providers, just to kind of abstract away the complexity of Kubernetes. And so to deploy your application, you just do an AC container app create, and you just deploy it, and you just pay for what you're using. But you can also enable Dapr. So if you're saying, I want to run this as a Dapr-write application, you just add these extra parameters. So enable Dapr, and again, specifying the port, the app ID, and so on. And of course, this is much more simpler than to actually spin up a Kubernetes cluster and learn all about these various deployment manifests and so on. So it's still in preview, but check it out if you're interested in microservices on Azure. And so actually, I have deployed this application that I just showed you. I have deployed them both to a Kubernetes cluster and to an Azure container app. So I just want to show you what it actually looks like. So I have a folder called deployment here, and I have one for Kubernetes and one for container apps. So let's just take a look. You can see I have 4 files here. One of them is related to tracing, so I will also show you how the tracing actually looks like. But I have one deployment manifest for my 3 different applications, the API, the web, and the warehouse API. And again, if we take a look at this, you can see that, well, if you're familiar with Kubernetes, you should recognize this is a standard deployment manifest. But what's specific here is this thing. I added this Dapper Annotations. And again, this is what actually will automatically spin up this Dapper sidecar next to my application. And specifying the app ID, the port, and the config in this case. That's all I need to add, actually. And the second part is the components. So this is now, again, exactly the same files that I just showed you. I just switched a few things. I don't want to use... actually, I need to specify the name of the Redis service in my Kubernetes. So actually, the endpoint will be a little bit different. But it's the same component files. And you can just apply them, deploy them in exactly the same way as you would do with a Kubernetes manifest. So, to deploy this, all I need to do now is to find a little prompt here somewhere and go to deploy. So I have my files here. I can go to the components, and I can do a kubectl, apply, and all the files. And it will just deploy my component manifest. It says unchanged because I did that before. And then I will do the same thing with my deployment manifests. So to show you this, I will take a peek inside my cluster to see what's running in there. So we can see I have my 3 different applications. We have the order API, order web, and the warehouse. Oops, sorry. I also have a Redis deployment running in there, so I can use Redis if I want to. And also we have the Zipkin, which is for the distributed tracing. So let's take a look at how we can access it. So we have the public endpoint here for the web. So again, let's take that one and browse to it. And not very impressively, it looks, of course, exactly the same thing, but now it's running inside Kubernetes, and I can use it in the same way. And I got a text message. But again, the application is completely untouched. I didn't have to change anything. I'm using Dapr, so it knows how to find the other components. I just added the deployment manifest, deployed it into Kubernetes, and it just worked. And that's a really nice aspect of using Dapr, I think, because everything is just handled by these components. And one of the building blocks that I didn't show you before is the tracing now. So I just want to quickly show you that one. So I exposed the Zipkin as a public IP, just to make it easier to take a look at it. So this is the standard Zipkin dashboard, and of course you could also export it to a lot of different tracing providers here. But you get a few things for free here. You get a really small diagram. So if you have very good eyes, you can actually see like the communication flowing here. So you can see the order web is calling the order API, which is calling the warehouse API, and so on. And you can also see traces here, which might be, potentially is more interesting. So here I can see the thing that I just did a few seconds ago. And you can see a lot of information about here, like how many times was this call service, was this call done, which service called which service, and so on. So I can actually dive into this one particular call, and I can see that the order web called the order API, and so on. So this is just for free. I didn't write a single piece of code to do this. I just enabled tracing in Dapper, and I got this kind of for free. So that's really, really nice. I also deployed it to Azure Container Apps that I mentioned before. So for the Kubernetes part, of course, I had to create a Kubernetes cluster and set up permissions and so on. So that's a little bit of a work, and I need to kind of understand Kubernetes. In terms of container apps, it's kind of much easier. So I don't need to spin up anything first. I just deploy my application, and Azure will deploy it for me somewhere in the cloud, and I will just pay for it, pay for how much I actually use it. So I have a deployment script here. So again, this is all that it takes to create, or actually to deploy an application. So I use the AC container app create. I don't have to use Dapper, of course. I can deploy any containerized application like this. So I just specify an environment, and an environment is actually created up here. So this is really the only command you need to run first to create the environment. So under the hood, this is actually a namespace in a Kubernetes cluster somewhere, but you don't really have to know about that. You just create an environment for your application. So it's like an isolated boundary where the services can talk to each other. And then you deploy your application into that environment. So you just specify that here. You're specifying the image, if it should be publicly available or not with the ingress. And again, I have this enable Dapper and the Dapper information added to it. So let's take a look at what I have here. So I could do AC container app list, just to see what container apps do I have in this group. And it will show me, I hope, 3 container apps. So again, the web, the API, and that warehouse API is running there. One of them now has a public endpoint because I specified that. The other one is just internal. They just need to be run from the inside. By default, you will get this pretty strange URL. Of course, eventually when this thing goes GA, you can attach a custom domain to it and so on. But you get this kind of random URL, and again, you can hit that. And now I didn't run it for a while, and I think they're using kind of a low resource environment, so it will take some time to spin up the first time. So it's kind of similar to if you're using an app service plan, the free version, it will die when you're not using it. So it takes a few seconds the first time you hit it. And the excitement is enormous. Come on. And there we go. And it will work in the same way here, of course. But now it's running in the cloud somewhere and using the Azure Container Apps. And again, I didn't change anything in my application. It just actually just worked. So now it actually spins out the API behind the scene now. So again, if you're interested in microservices and maybe don't want to learn everything about Kubernetes, which is actually kind of a barrier to get into, it can be pretty complicated. Even though if you have managed services like AKS in Azure, but you still need to know a lot of things about Kubernetes. And when you start getting errors, you need to understand a lot of things. These are the type of services that will be coming a lot more now that will abstract these things away from you. So they are using Kubernetes to host your things, but you can just deploy your apps and pay for the amount of resources that you're actually using. All right, so that was a few options. Actually, I just also a slide on the Sdk languages. So I showed you .NET Core today, but there's a lot of SDKs for different types of languages. So you have a client SDK. That's kind of the basic of it that I showed you with the client, and you can all have these invoke methods. Then you have, for some of these languages, you have kind of an extra things like the server extensions. So for ASP.NET Core, for example, it just makes it easier to kind of connect a few things, and you can codify some things just more nicely. You can inject that Dapper client, for example, and so on. But again, you can use any language that you want, and that's really one of the key points here. And again, take a look at the Dapper IO site for more information. So, for example, I could show you. So if you go to the Dapper documentation sites, you can, for example, look at all these component specs that I showed you, or I showed you some example of it. So for example, if you're interested in the bindings, to see, I showed you the Twilio. If you go in here, you can see all the existing binding components. So here you would, for example, see Twilio down here. And you can go in here, and then you can see the documentation on the format, or how you actually use these things. But again, as you can see, this is it's a long list, and it just keeps growing with things that you can communicate now without actually having to write any code to do it. All right, that's actually all that I had. We actually have 2 minutes left, so if there are any questions, you can do it now. Otherwise, you can just come to me after the session and ask there, or ask in the Slack channel later on. But I will just end by saying a big thank you for coming to my session. I hope you learned something about Dapper, how it is, how it works, and how you can get started with it. And if it's the right tool for you, well, you have to decide that for yourself. And have a great rest of the conference. Thank you.